Hey, what's happening, guys? Welcome to another edition of Bad Boys of Amplitude Modulation. And today I've got something special for you. This has been a project of 2 years, broadcast transmitter, Bauer 707. Let me crack the door open for you here. Oh yeah, 4400s by 4400s. It's a kilowatt transmitter. And hey, we're going to go through it all. I'm going to show you how I did it with a little help from a friend. And let's get to it. So, Bauer 707. This was a kit and or a made unit, depending on how you purchase it. Most radio stations back in the day purchased it as a kit. The engineer would build it, save them some money, and they were nice. They actually made approximately 500 of them. This is serial number 269, and this unit is set up for 1,500 watts. And it was on 980 AM. It was the first Spanish-speaking radio station in California, in Salinas, California. Okay? So, it's 75 inches tall, 30 inches wide, 25 inches deep, and you can see this powder coat. It is horrible. I threw some wax on this thing, buffed it, and the initial looks great, but then it's crap. It turns to this white paste. So I will paint it. I actually might plastic dip it. That's the brown just looks horrible. And I've tried using some what do you call it, rubbing compound and things like that. I probably would have to just wet sand it, but it's powder coated, so that's a bit of an issue. It weighs approximately 800 pounds. It's aluminum chassis, so it's one of the lightest kilowatt broadcast transmitters you can get your hands on. It's set up for power output of maximum 1,100 watts. What else can I tell you about it? Of course, 100% modulation. You're talking 4,000 plus watts at 1,100 watts. And I see this thing like on 75 meters running, 1,100-ish into a dummy load, of course, guys, into a dummy load. For, I can run it like 140% positive modulation, with, negative modulation looking, not flatten it out. So I even have the original manual they made for it back in the day, available completely assembled or in kit form. Now this was a kit form. I actually have the build manual for this original transmitter, number 269, which was pretty cool that I found that. So with some of the engineers' notes and things like that. So a couple things here. There's your 4400s, modulators, finals. It comes with this. This is a 500 puff vacuum variable. This I added, 40, 75, 160. And this is a 1,000 puff vacuum variable that I added. Okay, let's see what else I can show you guys. The only thing on the metering that I cannot get working, is this guy right here, this power monitor. There's an optical relay up behind this guy. I haven't messed with it yet too much, but as you can see down here, let's see if I can pull this off for you. That's a contactor. I had to replace the contactor that was original to it. It smoked pretty quick. And this essentially is like my push to talk. All right. We'll just put that to the side for now. This little guy's sitting here because I've set the modulator bias and the asymmetrical modulation, which is done. Somebody had a switch in here, and this had some stickies on here, and they would put their meter in and test what the finals were voltage-wise and stuff like that. I don't know, maybe they didn't trust the metering up here. So that's essentially what that's there for. So, I have my generic meter up here. It's not very good on peak, but it's for a tune-up. The side of this guy, I've added these. That is hooked up to the relay. This is my REA mod monitor sensor. That's for the receiver. I'll show you the stuff when I get to the inside. I didn't need to add this, but this is easier if I have like a VNA and stuff. I don't have to flip the relay and make it stay on transmit, power off, of course, and do some checking for tuning. I really don't use it as much anymore, but it's handy. It's handy that way. Rack full of gear. We can get into that a little bit. And this is the rig that I use to run it and for the receiver. It's a bit overkill. I really don't like using the rig because it's really a nice rig, but I can run it use the rig normally because it's hooked up the way it's hooked up. I can just go right out to the antenna, hook up this microphone, and just run the rig sideband or whatever, no problem. My antenna matching network. So let's go around to the back and I'll show you what we got going on back here. All right, so we got this door open here. Let me make sure I got this baby on wide. I'm going to explain a few things. First of all, these are the photos of the machine before. Just put the photos up so you can see that. And this is what it looks like now. So I burnt up a choke. This is a replacement choke. High voltage choke, or plate choke, I want to say, plate choke. This is the input. That's the output. This is the large L7, they call it, L7 inductor. There was another inductor for the output up here. That's gone now. This is the other one. This is called a Pi L, all right? So, tap, 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 initial tap. And then you got tap, 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 and then that's tapped to the output. So it's just like tuning up an amplifier. I'm just going to try and keep this as elementary as possible. Let me step back a little bit and go back to when I initially got this thing. Let's go down. Let me show you what I had to do. This is a rectifier stack. Full wave bridge, half and half. Initially, this was in here with another one. When I fired it off, I would blow the K10 safety, which is right here, right down here. K10 would blow, this would go, and what I mean blow is this is a resettable safety, would pop out. But I was also blowing, if I kept doing enough, I'd blow the main fuse, which is not good. So essentially I was having a straight short to high voltage. So checking everything, just going through the whole thing. I mean, we're talking, this was crazy. Let me make it wide again here so you guys can see. So you have the high voltage transformer. That's the modulator reactor. That's the mod transformer. That's the high voltage choke. You've got the big capacitors in there. What else can I tell you? It had a thing for, you can raise and lower the power, kind of adjust it a little bit. That doesn't seem to work now, the way I have this hooked up. This box was where the oscillator crystal was. You had a choice of 2 of them. Now this is called a Sola. The Sola we had to snip when I removed the transmitter initially. And at the end of this video, I will show you the photos of the rescue when we got it from the radio station. But this was snipped. I put it back in. Now what a Sola does is it keeps all the low voltages even, no matter what your input voltage is. So it'll run better that way. Back to the oscillator circuit. So initially, this little SO239 came up here and had another one of these. Whoever had this is a pickup for the oscilloscope that you can hook up to it, to a scope or a mod monitor or whatever. They had a pickup over here also. I don't know why, but that's how it was. So I disconnected that because I didn't need 2. And to match the input of these 400s to my transceiver that I was driving it with, I built a 49-to-1 balun, because it's somewhere around 3,000 ohms, probably a little more. I initially had 1 core, and it was kind of heating up a little bit. So I went to 2 cores, and all good. No problem on the heat up. It stays, SWR stays fine with that big tuner I showed you. No problem at all. And so it drives, whatever drive I need goes right into these 400s right here. What else? Modulators. Now this unit, you can see it's charred at 500 watts, running it at the 500 watt level, which it will run fine there. These 2 big resistors take up that extra juice and lower the plate output so it'll run in the 500 watt realm. So you can see the heat from those. And they run just fine. No problem there. So let's go back to the rectifier stack. So the initial problem we couldn't figure out was, why was I getting this short? There was so much in the short. I mean, I went through everything, testing all the heavy metal with, various pieces of test gear. Anyways, initially, there was 1 shorted rectifier. We knew that, but they were opposite. So I built another string. And this is way overkill compared to this one, but it's fine. It's with over spec, but this one's just fine. This stuff was not available. I just wanted to replace it, have a plug-in. These just come out just like this, all right? That's it. I don't want to change it all. So I took the old one, and I've got little plugs just like that, and this plugs right into it. So initially what happened was, whoever had this set up before had the rectifiers backwards. I didn't know that. We didn't know it. So putting these in, this guy was up here, this guy was down here. I still had a hard short. The rectifiers were backwards. I swapped them. Boom! I'm on 980 AM. So that was number 1. Number 2, the initial checkout found that this choke was bad, the high voltage choke. All right. It's bad to ground to the case. So if you look down there, you can see the piece of wood. It's floating on that. Works fine. All the other heavy metals in good shape. What else do I have got going on here? So it was now time to figure out how to put this thing on 3 bands. Now I can also add a 20 meter tap, but I haven't done that. I just really don't get on 20 that often on AM. So we had to figure out what taps we needed, doing a pi L. So you've got the input, output tuning, input tuning. This is your safety here. And so my buddy Joe, KA1BWO, he is Mr. Technical, because I'm not. He ran it through a couple programs, and we had a ton of iterations of testing with this thing. And let me show you what was happening. There's a couple pictures of the ceiling. We're having flashovers. I mean, I was starting fires in this sucker. Probably would have made good video. I should have videoed it, but anyway. So things weren't working. It was working, but it wasn't tuning quite nicely. It was a mess. And we found out that initially we have to go from here and start off and use this whole thing. What we were doing was saving a tap on here and starting here and using this section only. And so there was a lot of voltage here, and it was flashing over, especially on 40 meters. So you can see some of this RF burns that I've cleaned up. But yeah, the whole ceiling was toasted, as you saw. So once I did this, and this is a 40 meter tap, this is the 75 tap, this is the 160 meter tap. Now with 160 meters, I had to add another 1,000 puff of capacitance. And so that is tuned in when I go to 160. So, and then you have taps here on the output inductor. Essentially the same way. Joe figured out what taps I needed to go, and away we went. So, there was a month long of testing on this thing. If you get one of these, it's not an overnight project. I will tell you that. It is not an overnight project. So, let me flatten this out a bit here. This guy is my transmit receive relay. All right, that's what you saw, the SO239s on the outside. No problems on current here. This thing is rock solid. It works well. It'll last many years. I had some of this funky loom. I had it on there before, but yeah, it was odd. And being that this is powder coated, man, I really got to grind the crap out of it to get a ground on this stuff. So there used to be a dummy load on these things. This one did not have the dummy load with it, unfortunately. It would have been nice to have the dummy load, but I do have a big oil-filled can. So, and also you can see this white wire here, this high voltage wire. I redid the whole high voltage wiring harness, thinking that we were showing some issues with the initial problem before we figured this situation out. Thought there was some flashovers and stuff like that going on with the high voltage harness, so I replaced that. And honestly, it's probably a good thing anyways, even though it didn't need it after the fact, but got a new high voltage harness in there, caused less problems later on. What else can I tell you? All right. See this right here? Let me zoom in a little bit. This is pulled. This is for the audio. This is an audio pad here. I have it jumpered now. So when you go from 500 watts to 1,000 watts, your audio input changes. You have to change that on your audio rack. But what this did was you had, let's say a 300 ohm and, I don't know, 180 ohm. So at the studio, you wouldn't have to worry about changing the audio on the rack. You could just leave it and it would automatically pad your audio to whichever power level you were using it to, because you might have too much on one or too little on the other. So I was kind of sick of jacking with the thing, so I just jumpered it. And the way it is, you got to clip one and jumper there, so I don't have any pads now. So yes, I have to make sure that I have my audio set up depending on where I'm setting this thing up at, into a dummy load, of course. What else can I tell you guys? So cooling. Let me get over here. So here's the fan that is from the factory. And it actually works great. I should probably put a little oil in there and figure out how to do that. That needs a little service, but it's not that bad. You'll hear it. It blows a lot of cool air, and this thing stays pretty damn cool even when I'm sitting out here and it's 85 degrees outside, which you really, and it's probably warmer in the garage, but you really, you know, these things aren't really set up for that. But it stays cool. Give you another shot of stuff here. Go right up the bin. So, let me give you a demo on the transmitter in operation, and we can talk about that. All right, so I want to talk about one more thing, okay, guys? This is, so you look on the internet, you're trying to figure out how you're going to do this whole situation, right? There's a lot of information on the Bauer from multiple people. All right. These are all modifications to get this thing working properly from multiple sources that I checked out. And most of them, all right, when Joe ran the numbers, there was a lot of problems with out-of-band stuff. Like, say you're transmitting on 3885 and then it's showing 10 watts, 15 watts in the 20 meters. You definitely don't want that. So you got to look at these things and do proper calculations for the Pi-L tank network. What else can I tell you? KD7RIX, he has a Bauer. He runs his with a 706. He gave me the idea of how to set this one up. He helped me out a little bit too, so I want to mention him. Gave me some good ideas. But I can tell you this, it gets very confusing if you've never done this. This is my first time with this sort of thing. There's been multiple numbers happening with these things as I went through it all. I mean, it gets crazy. The schematic for the Bauer. This is where things need to be run at for proper power, 250 watt level, and all your numbers you want to match up pretty close. Manual for it. What else can I tell you guys? There's one sheet that I'm looking for. Here we go, right here. That's what I was looking for. So this is an earlier one, but this is essentially how things look for the 41025 setup. We just have different taps and things. All right, the initial setup, how we were doing things of 23.5 on that big L7 inductor. That's fine. We have similar numbers now after 3 different renditions, but I'm tapping that input direct to the end of L7, and then I have separate taps going across. That took care of the problem that I was having with the flashover stuff. Not flashover, but the resonance. So let's get to working with this stuff here. Let me zoom in a little bit so we have normal. We're not wide angle. So I'm already on here. Now, now for the 500 watt level, I can run AM, but for as far as enough input power to the transmitter. But if I want to run 1100 watts, the full power into a dummy load, of course, I need to run it in CW, and I just use this key to lock it down for the right input level. And I'll go ahead and put this into the dummy load and show you what's going on. So first thing I do is master start button. Let me make sure we got you on here, guys. Here we go. All right. I'm going to leave it on high. This doesn't matter anymore. This really doesn't do anything. Let me zoom out, give you guys a little bit better shot. There's the 4400s lighting off. Boo, 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 boo. I'm going to put on the low voltage. It'll start coming up right there once we get warmed up. There she goes. Audio plate. None of those will come up until I rock and roll. Now, what I'm going to do is I can put the high voltage switch on right now. It will not come on. Usually, in normal operating, like at the radio station, as soon as you throw that, that baby is on the air. And all these are lit up. But I want to show you. Got my rack set up. All right, so this is my setup. So I go, normally, we're on AM. All right. And I'm in a dummy load, so I'm not really hearing antenna-wise. So I'm going to try and get this off-center so you guys can see it. And let me zoom in a little bit here for you. All right, that's better. So that's my receive. So when I want to go to transmit, I have to press antenna 2. And if it's just running low power, AM's fine, but we're running high power right now. We're going to run the full out. So I need to go to CW. Now it won't key up right now because I don't have the high voltage switch on, but I wanted to show you what's going on. Zoom in a little bit. I've got this light going here, but I need it for other shots. I'm going to hit this. I'm going to hit the mic key. I'm going to hit the CW key. So there's my power. I'm going to check my SWR. My SWR is flat. This is going to that 49-to-1 balun. So I'm going to walk over here, and I'm going to look at the drive level. So it's showing, 22, but I don't need that much. I need 18 to 20 or 14 to 16. That's the 500. That's the kilowatt. So when I key down, when this actually keys up, it's going to drop. There's your power right there, 1100 watts. Zoom out, power's off. So normally what I would do if I want to use push to talk, take that off. I turn on high voltage. The transmitter needs a certain amount of input final grid in order to transmit. That's just how it's set up. It will not transmit with a low, say 1 watt. I have to drive this thing. So let's go over here. I also have the mod monitor set up. That'll make less, take that light off. So I'm going to key this down. That automatically keyed up the transmitter. Hello, test 1, 2, 3, 4, 5 at 9 AMI. Now look at, that's very nice audio right there. Hello, test at 9 AMI. Testing 5, 4, 3, 2, 1 and 9 AMI into a dummy load, and just hear a little bit of talk back, but it's supposed to be like that. Looks very good. It's, the negatives aren't even coming up, so it's right on power. And let me go and walk over here and show you guys what I have going on. So there is the watt meter that I'm just killing it. The mod plates. I'm actually a little bit low. That should come up a bit. Everything else. right where she needs to be, pretty much. Vinyl grid. I'm running like 16, 17. It likes it right there, so that is fine and dandy. I could come up a little bit more with it, which I will do. And there's probably where it should be sitting right there. Hello, test 1, 2, 3, 4, 5, 6, 7, 8, and 9 AMI. And I can show you how I do this. It should be set at, according to the book, 110. So I just take my little screwdriver, bring it up here, and draw that up. There's 100, and we'll call it 110, right around there. So that's where it's supposed to be. There's the big old dummy load that I'm sure is heating up pretty good right now. Hello, test 1, 2, 3, 4, 5, and 9 AMI. And 9 AMI. Beautiful. And yeah, then I would undo it. I hit 1 AM, and I have my receiver going. Pretty simple. So this is the rack gear I'm using. Euro Rack Pro, so I can have multiple microphones. It also has effects if I want, that kind of goofy stuff. I'm using, next in line, I have my Composer Pro. That is a compressor, expander, gate. Then I have the Ultragraph Pro EQ. Then I have another compressor, a Harris MSP90, that does expansion and AGC amplifier. It's a compressor. And this guy is connected to the computer. I can send or receive audio from the air to record or send out if you want to, you know, just for experimental purposes. So that's essentially the setup on that. This guy works really nice. It's no Optimod, but it does work well, and you can tailor the audio to how you want it. I've got mine about, this will be 20K wide if you want it to be, because if it's a broadcast transmitter. I've got mine, it's 10 to 12, right around there. So it works well. And as you can see, the EQ, it kind of comes up on the 100, then it drops right down and slowly comes up through the mids. And yeah, you're dropping right off 4, 6, 3, boom, 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 pulling down really quick. So I'm not using this side. I could actually hook up a set of speakers to this and, you know, have that kind of going too, but nah. So that's essentially the Bauer 707 project. And yes, it did take 2 years to get going here. It was quite the headache, I can say that. It works on 40, it works on 160, no problem. The 40 meter tap, I need to advance it 1 tap for tuning, because I don't like, it said I had 100% modulation, but it could do a little bit better, because you just saw on 75, which is the same on 160, I'm getting like 130% positives if I'm driving it that way. So I want the tuning to react better, so I'll add a little bit more inductance from that big L7 that you saw. And you can tell it's not very loud. If I walk back here, you know, you've got the fan back here and stuff, but it's not bad. So that is the Bauer 707, and I'm going to throw a few pictures up at the end here from the rescue. Me and my buddy W7MS, he rode along to help do the rescue, do the heavy lifting, and that was it. I had unloaded it myself actually when I was in the garage here, but that's the deal. What else can I tell you about the situation? I added the wheels to this. You always want to add the wheels, or else you'd never be able to push the darn thing around. This guy down here, you're probably wondering what all this is. So this is cabling. This is the audio input. This stuff is for, it goes up alongside, is for that power monitor, which I haven't got going. Let's see if I can show you guys this at all. It's up here. Let me tilt this back a little bit. It's a little wonky. It's up here. Got on, off, high, low, and I just have this pulled over here just for video. Usually I have it hanging down. So there's an optical relay up here and then another ice cube relay, which is actually fine, the ice cube relay. But yeah, so I don't know. That's the next situation I'm gonna have to see, because I would like to use that. I could just remove this piece of junk, and I have a nice little power monitor here, and that is the efficiency factor when you got it tuned up properly, 72%. That's pretty good for tubes. That's it, guys. Watch the run of pictures here from the rescue, from the radio station, and the Bauer 707 broadcast transmitter. I did not pay for this. This was a rescue. It was free, although free, as you can tell, isn't always free, because this was floating around for 2 years. Spent a couple $100 in parts, and of course a couple $100 in fuel to pick it up, and many hours of labor time, especially the last month or so. So that's the deal. That's the transmitter. Catch you on the air. Like, share, subscribe, the Wavelength Radio. Spread the word, and definitely do some more videos like this, because that's kind of what I like doing. The next up, to give you a little taste, will be the history and all that doodads on this T368 transmitter, which is pretty damn cool. Military transmitter, but it's modified a little bit, has a little bit of history in the ham world, and we'll talk about that next time. Thanks for watching.